grading tumors, and I gave you an example going back in medical history, set by brothers who observed lid carcinoma. You may remember 75 lessons, 75, all those numbers, grade 1, grade 2, grade 3, grade 4. I also talked about the different approaches to evaluate the proliferative potential of tumors, both benign and malignant. Because don't forget that there is a slide in there. I will have to replace, I had already put on the website this lecture, but I changed it, the second half. So I will take the one that's on, off, and replace it by this one. But even in the previous version, there were several different approaches to use a quantitative numerical approach to evaluate the proliferative activity of tumor cells. And I'm not sure, because I always have this problem, what did I say to the Hungarian students and what did I say to the English course, during the English course, but I would like to call your attention to the fact that there are immunohistochemical methods to label cells which are in G0, not in G0, anywhere else in the cell cycle. And that immunohistochemical marker is an antibody that has the name of MIB1. And we also can quantitate the labeled cells with MIB1 antibody. So that's another approach to give a numerical evaluation of the proliferative potential or activity in cells. Now, getting back to characterization of malignancy, grade is a broadly accepted, worldwide accepted category or feature which, no matter where you go home or where you go to work eventually, if you read a pathology report on a malignant tumor, then you will inevitably encounter grades, WHO grades. There is a whole series of books, the Blue Book series, as it's well known within the area of pathology, which gives more or less uniform directives to give the grade to colon cancer, lung cancer, brain tumor. Please don't drink, okay? I would love to have a coffee. I would give anything for a coffee. You know, the thing that frustrates me to no end. I started to work, I had 3 lectures today. This is the third. Started to work on them yesterday at 9 o'clock in the morning. I finished my work at 1:30 in the morning today. And then I had this many people who are interested. So I would die for a coffee. Doesn't have much, by the way, but I love the taste. So grading is a general thing. Don't forget one thing though. It's subjective. Never fall for the mistake of considering a grade a golden number that is absolutely reliable. I have a good friend in Belgium, Van den Bent, Johannes van den Bent, who is a neuro-oncologist. who once collected brain tumor specimens and slides. And within an area, a specialized area like brain tumors, internationally we know each other. So we all know who are those who we consider the best in diagnostic work in brain tumors. So Johannes decided to send the same slides, not series of slides. Everybody got the same slides, 10 eminent neuro-oncopathologists. There were 100 cases of brain tumors. The question was, please grade them. And the result was just dumbfounding. There were cases where the agreement was less than 20%. And we're talking about people who spend their lives. One of them is dead now. It happened about 3 years ago. Less than 20%. And the most significant differences were between grade 3 and grade 4. So, any time when you will encounter a brain tumor, or no matter what type of tumor, biopsy with a grade, and there is any inconsistency between that grade and the clinical picture, never hesitate to ask for a second opinion. And never be surprised if the patient asks for a second opinion. Because patients nowadays are very well educated, particularly those who have a fatal disease. They would go to the internet and get every information, including grading and including problems of grading. That's why it's important. But in addition to grading, which we do on a regular basis, there are other features of the neoplastic tumor that are important. And the next broad area of giving help to patients and giving help to clinicians is staging. And I should have a better, larger version of this, I think. There we go. Stage, if you want to use the original meaning of the English word, stage is the theater one. There are several meanings, but if you use this mnemotechnique that you associate stage with the theater and with a drama that takes place on that stage, then staging will make sense to you because it describes to you where the action is. Where does that drama, which is the neoplastic cell spread, happens in the human body? That's what staging is all about. Often, students mix the two things, grading and staging. But if you associate staging with the theater and the drama, because a malignant tumor is a drama, a fatal, tragic play, interplay between the host organism and the tumor itself, then you will understand that staging expresses or gives you information in a given concrete patient's case where that whole disease process happens and how it happens, which includes three things staging does. One is the size of the tumor, abbreviated and marked by a T, and two other features: how far did that tumor spread from the location where it originated from. And that includes lymph nodes and other organs, or the same organ for that matter. If there is a primary tumor of the liver, that tumor can give metastases to the liver, and the lungs, and the bones, everywhere else. Where does that happen? The action. What is the stage where it takes place? That's expressed by T and N and N. But it's not that simple. And mark my word, those who are not present will have a hell of a time if they have to talk about T and N and staging during the examination. Because it's my experience that most of the students who do not come to lectures come to the examination and think that staging is the same as the T and N, which is not. And I will try to convince you why it's not. But as a start, it's worth remembering that T refers to the size of the tumor, N refers to the lymph nodes that are involved, and M refers to metastases. Now, T usually refers to the primary tumor, and the size is expressed by numbers that are suffixed to the T itself. And it is very, very important that the size is different, which means the numbers suffixed to the T are different if it's a tumor of the lip, just to use the same example as I used for grading, or if it's in the colon. And again, I talk about that next semester when I will talk about colorectal cancer, and I will call your attention to the fact, and I'm telling it now as well, that the size of the tumor, for instance, in colorectal cancers, is not necessarily the actual physical size expressed in millimeters. Much more the extent of invasion of the colonic wall. So T, while it is a size measurement of the tumor, may express different things depending on what organ and what type of tumor we are talking about. Two important things: T0, no tumor. TIS, in situ carcinoma. Benign tumors do not have stages because they don't spread. For those who are ready for some intellectual challenge, just leave you with a question. Does it make any sense to talk about stage when we talk about an in situ cancer? No. It has not yet spread. But contradictions like that exist in this whole system. So TIS refers to a stage where stage is meaningless. Nevertheless, we still have TIS within the staging T category. And as I said, refers to the lymph node status, number of lymph nodes, but it's not that simple. N1 does not equal with one lymph node, and N2, two lymph nodes. Therefore, TNN is a simplified but not full picture of staging. I'll get back to that later. And M refers to metastases. Again, M0 denotes absence of metastases, but that is a complicated issue again. Why? Because we can talk about different types of T's and N's and N's. There is an image in every clinician who treats a patient with a malignant tumor. about what is the size of that stage where the whole drama takes place. So it is possible, particularly since we have all these sophisticated, highly developed imaging techniques, to give a clinical TNM evaluation of a tumor, and also a pathological, so there is a cTNM, a pTNM, there is a TNM after treatment, both referring to the clinical and the pathological TNM system. There is a different separate TNM numerical value if the patient had been treated by surgery, chemotherapy, or radiation, or a combination of thereof. So there is an RTNM, and of course the most precise is an autopsy TNM evaluation. Now here you go, and you can see why I said N1 is not one lymph node. This is a theoretical situation. I don't even care where the primary tumor is. But you can see that the size may vary. You can also see that the degree of lymph node involvement may be different. But in this case, and in many cases of the use of staging, N1 will refer to more than one lymph node involved. And N2 does not mean 2 lymph nodes, but several. And the extent of metastases is depicted by this picture. So in this case, the TNM value will be T2, depending on the size, which again I emphasize is organ dependent, the actual physical size. And you will hear about melanomas where the depth of the invasion of the skin is decisive for the patient's future death or life issue. And 1 and 0. And if I want to give you a more detailed explanation why T and N is not a simple description of staging. If you look here, you will see that there are several different numerical possibilities. Stage 0, stage 1, and stage 2 are simple. The only variable is the size of the tumor. But stage 3, and this is what the patient will tell you. Doc, I have just gotten my evaluation and I have a stage 3 lung carcinoma. What does that mean? And they will be direct, and they will say, how long do I have? How long am I going to live? How much time do I have to take care of my family, my will, my business, if my tumor is stage 3? And if those who are not here, and they will not understand this life, they will not be able to give an honest, reliable question to the answer to the question, what does T4A? Or what does T4B or T4C mean in the case of stomach cancer, melanoma, lung cancer, brain tumor, or lung cancer? Okay? So that's very, very important. And I can tell you, I did not put the numbers there, because I don't think it's necessary for you to try to remember numbers that are not necessary to remember. But in the case of liquor carcinoma, T1 is less than 2 centimeters. T2 is between 2 and 4 centimeters, and T3 is larger than 4 centimeters. And these numbers are decided and determined by a group of oncologists from all over the world, including Japan, Australia, the Middle East, and even Hungary. and based upon observations of tens of thousands of patients. That will determine that in the case of lip carcinoma, T2 is between 2 and 4 centimeters. And based upon this much, you must understand that staging is much more important from the point of view of the patient than grading is. Even if they are not aware of the fact that grading is subjective. But anyone will understand that if I go to the doctor and the doctor tells me that, well, my friend, you have tumors in your bones, in your lungs, in your liver, in your brain, that's much worse than if the case is you have one focus of malignant tumors which are melanocytes transferred into a malignant cell type, so you have a malignant melanoma that's localized here. Simple. Okay, another issue that is very, very important. Whenever we try to get information about the biological features of a tumor, we try to find indicators of that biological behavior. And indicators in this regard are referred to as marks. And if you think of a mark, again, is there anyone here whose mother tongue is English? Typical. They speak better English than I do, so they don't come. Though I have asked several of them to correct my English, they just don't do it. Anyway, a marker, you're all familiar with, a fat pen, where you can take it and mark that. Okay, to show you something, I take a marker and did it work, I could have marked that board. Just simply doesn't work. Surprise, surprise. Would have been really surprising had it been possible to use it. So much about this medical school. But I can, if I have a marker, I can try to make use of this nonsensical situation. If I have a marker that works, then I can mark something with it, right? Then what I used it at would be marked. I can turn the whole situation around. We can look for marks on that board which would tell us that somebody had used a fat pen on that board. So the trace would tell me that somebody had been there with a marker and left a mark on that board. The same logic applies to trying to recognize tumor cells and trying to understand the behavior of those tumor cells. And those features which tell us that information are being referred to as markers. I did put down here a definition. It's more complicated. It almost looks as if it were scientific. But that's what is possible to say about a biomarker. It's a characteristic and a feature that in an ideal situation can even be measured. So quantitative value can be associated with a feature that we recognize as a characteristic feature of lung cancer, breast cancer, blah, blah, blah. I won't go into this, but genetic markers are different. And you may already have read, I'm not asking, but just commenting on the fact that it is being used in the chapter that deals with genetics. But genetic markers and marker association is somewhat different, so don't mix the two things. The markers that are used in oncology and the markers that are used in genetics. That's a more conventional definition. Markers are products of malignant neoplasms which allow us to draw conclusions about the biological behavior. Don't forget, there's no marker, none, and I doubt there ever be one, that will tell the difference between a benign lesion and a malignant lesion. No matter how sophisticated the technique is. Because malignancy, the bad behavior, is the result of a complex interaction of many different factors and features. So there's not one marker that could reliably tell us whether a skin lesion is a benign nevus or it's a malignant melanoma. And that's just one example. There are 3 different types of markers, and this is very important. One type, one class of markers is those features that help us to identify the lesion. Not surprisingly, these are called diagnostic markers. There is another group of markers, tumor features, that will inform us about the prognosis. Like the weatherman tells us whether or not it will rain today. Doctors also tend to try to inform the patient how long they still have to live. In other words, how long will the cancer kill them? And I hate to say this, but often pathological prognostication is even worse than weather. And you know from your own experience how reliable those things are. And there is a third group, and those markers are predictive. They predict, tell ahead whether one given drug, medication, will or will not have a beneficial effect on that population of tumor cells. Diagnostic markers have to identify. Don't forget that there are several different features that we can use as markers: genetic, epigenetic, molecular, cytologic, histological, blah, blah, blah. The most important is immunohistochemistry. The good example is a small blue cell tumor, which can be leukemia, rhabdomyosarcoma, osteosarcoma, a lymphoma, small cell lung carcinoma, all look alike. Small blue cells, like lymphocytes. And unless we use diagnostic markers, we have no chance of determining where that tumor originates, which will determine our ability to treat that tumor. Or this is a typical situation in a case of a metastatic cancer of unknown primary. The patient goes to the doctor, there is a nodule in the skin which is removed, and it turns out to be a gland-forming malignant epithelial tumor, which is an adenocarcinoma. And then, obviously, both the patient and the doctor are curious, where is the primary? And often, we just cannot tell. Even if we use the most sophisticated genetic, epigenetic, molecular, cytologic, histologic markers. And it's not because the tools are not available. Often that happens too, because there's not enough money. But even amongst the best possible situations, again, the statistics that I can refer to, about 30% of cases of metastatic tumors are not possible to identify as the metastases of a concrete given primary. That's a huge number. And needless to say, in many cases, nowadays still, the best way to treat a primary is to remove it. But how can you remove it if you don't even know where it is? And no matter how sophisticated the imaging is, that scan combined with CT or MR, or all three, and still, lots of tumors foci within the human body, but which one is the primary? And the diagnostic markers often help us to determine them. Very important these days is that it often is not necessary to remove a piece of tissue. It often is enough to take a blood sample, and that's called a liquid biopsy, or a CSF sample, or these other two. Urine can also be used for detecting fragments of tumor DNA, RNA, cell fragments like exosomes, and get information about the tumor's characteristics. So it is an important way. I wrote down here the different types of exosome analysis, but I would skip those. You will find them on the internet. But I will go into the practical issues. Cell lineage identification often is done by immunohistochemists, and you have heard a whole lecture about immunohistochemistry, so I will go into details about that. I'll give you a few examples. Carcinoembryonic antigen is often useful for GI tract tumors. CA125 is an indicator of ovarian cancer. Prostatic specific amylase is PSA is a good marker of prostatic cancer. But just to stay with that last one, PSA levels may increase if somebody has a prostatitis. CEA levels may increase if somebody has an inflammatory condition of the GI tract. So these are not specific enough. They often are very useful if the primary tumor is removed. The patient goes back for control every 6 months, and the levels of these markers are checked. And if there is a sudden rise, that means that there is a recurrence, or there is a group of tumor cells that have behaved previously as dormant cells, and suddenly the tumor flares up and a new bulk develops. So they are often useful. Plus, they can also be used to check the efficacy of any treatment, surgery, radiation, chemotherapy, or a combination thereof. A prognostic marker is to know ahead, and that will tell us the length of overall survival, the event-free survival time, event-free survival in a case of a malignant tumor. And this is represented, for instance, in the case of a breast cancer. We do the immunohistochemical analysis of the tissue identify estrogen, progesterone, and the HER2 marker, which is an EGFR receptor, by the way. And using these features, we not only can diagnose a specific type of breast cancer, but we can also come up with a prognostic statement. The same thing holds true for an oligodendroglioma, in the case of which the co-deletion of chromosome 1 small and chromosome 19's long arm 1p19q co-deletion is not only diagnostic, so much so that as we speak, nobody can write down the official diagnosis of an oligodendroglioma unless there is a co-deletion of 1p and 19q. But also, we know that those patients who have a tumor that is characterized by 1p19q co-deletion have a much longer 5-year survival time than those who do not have 1p19q co-deletion. So this feature is not only diagnostic, but also prognostic. And in this case, predictive too, because those brain tumors which are characterized by 1p19q co-deletion very favorably respond to PCV therapy, which is procarbazine, carmustine, and vincristine, than to Tamodal, which is the most commonly used chemotherapeutic agent in brain tumors. And if somebody gets the improper, ineffective chemotherapy, then only the side effects will appear, no benefit from that treatment. So the patient still will be vomiting, losing hair, losing weight, feeling sick, and no beneficial effect on the tumor. So getting the right genetic profile for a tumor has to avoid side effects, unnecessary side effects, and makes treatment personalized, which is the long-term aim of medicine. And by the time you get your diploma, you'll get much closer to real personalized medicine than what we are at right now. Yes. So once we identify a tumor and we say it's a brain tumor, and we determine markers, and there are almost like a cookbook. And since my major focus is brain tumors, I have several different internationally, I will show one example, internationally suggested approaches towards a brain tumor, which I use based upon the phenotype, then the diagnostic markers, but as I use the diagnostic markers, some of those will automatically become not only prognostic but also predictive. Okay? And this is the etymology. Prognostic and predictive is a difficult issue in English, but mainly for those who pay attention to such details. And there are a few predictive markers. For instance, estrogen progesterone receptor, or HER2, will allow certain types of hormonal treatments of breast cancer. If the promoter of methylguanine methyltransferase, the enzyme, is methylated, then there's no use to give any type of drug that makes covalent bindings between certain amino acids and within proteins, or covalent bindings between certain segments of the DNA, because this enzyme will correct that error that is brought about by treatment. and EGFR in lung carcinoma, c-KIT in GI stromal tumors. Plus, some of these predictive markers can also be, or diagnostic markers or prognostic markers, like CD20, which is a B-cell marker, eventually just in parentheses, for a B-cell marker you will find in Robin CD19, which we never use. We always use CD20. But CD20 characterizes B cells, so if we have an antibody against CD20, we can block the proliferation of B cells, so B cell lymphoma can be treated by that. This is described here. Now, this again is about the liquid biopsy thing, and you see we can take I don't think that's adult behavior. Even here, not only in the autopsy. Circulating tumor cells, blah, 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 can be done. And this is the, if somebody wants to read further on liquid biopsies, you can access that on the internet. This is from last year, this image. Now, this is the thing that I said about brain tumors. Isocitrate dehydrogenase is not only a diagnostic marker, but also a prognostic marker and a predictive marker. And that leads us to a more complicated thing. This is, how do we write, and thank you very much. This is how we have to write a report, a pathology report in 2017. And the approach to that is named layered diagnosis. 3 years ago, as I was, no, 2 years ago, when I was writing pathology reports about brain tumors, I usually wrote, this is a grade 4 astrocytic tumor, glioblastoma, WHO grade 4. It's not enough anymore. Not enough. We have to include all information in the report. And when in 2014 I was invited to the International World Meeting of Neuropathology, and I had the great advantage of visiting Rio, a wonderful city. We spent 2 days there with all those well-known international specialists in neuro-oncology, how to present the information. Because one of the things that you will eventually have to face is the big data problem. And I guess you're already familiar with it. There's just too much information. And it needs to be put together in a concise way, but at the same time in a way that will help the patient, first of all. And then somebody, that was David Lewis there, who came up with the idea, we need to write the report as a Google map is put together. And if any of you has ever wondered how does Google do that, it's an amazing trick, because there is geographical information there, height, above the sea level, and the different actual surface features, including buildings and trees and whatnot, and then the mapping, so layer by layer by layer by layer. The end result is the map that you can use on your phone and find your way around a big city like that. Okay? So that's where the whole idea of a layered diagnosis comes from. And I must tell you, it's subjective, but I have never in my life actually witnessed how an expression is born that eventually I end up teaching. Lay a diagnosis based upon the Google map, created by David Lewis, who is a wonderful guy, and loves Hungarian classical music. In addition to knowing probably the most about brain tumors in the world. But these are the features. That's something that I will get back next semester. But before I leave you today, there's one more very, very important thing I want to call your attention to. There are axioms that govern. For instance, if you look up the 10th edition of Robbins, the latest, which is published, I think the publication date is 2018. Check that. Because of, I don't know, what type of policy. They probably ran out of the number 7 in the printing factory. But I think that is the book that is already marked as 2018. And it will still tell you that malignant tumors are monoclonal. No. And that's important. And I get back to that. Plus, we now know that tumors usually do not focally evolve, but evolve in a field of tissue. And I'll give you one example that will make sense to everybody. If we consider carcinoma of the urinary bladder, which is most often caused by carcinogenic effect of solute substances which are dissolved in urine, that will affect the full surface, mucosal surface of the urinary bladder. And therefore, it's a well-known and has been well-known for quite some time that urinary transitional cell carcinoma of the urinary bladder usually arises multifocally, which makes life very, very complicated when it comes to treating those tumors. So that's the field theory of carcinogenesis. It's not a linear process, but it is like the tree, trunk, and branch. We'll show you an image for that. And what's important here, that at each branching point, now we know that there are cancer stem cells that will result in several different groups of tumor cells. And you may remember this, I already used this once. And you can imagine using this rotten apple, which is probably my best idea I have ever had in teaching. Because then it makes it very easy to understand that if we have a solid tumor, be that brain tumor, laryngeal tumor, lung carcinoma, liver cancer, and the surgeon goes into that area where that tumor is, takes one biopsy out, chances are that the most important features, markers, the grade will not be representative. So sampling is of utmost importance. And it's enough to think of, if I put my needle here, 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 or just to the edge, my diagnosis will be different. Not to mention the prognosis. And since I will be using techniques to get markers, diagnostic, prognostic, and predictive, most likely my treatment will be useless. So whenever you hear all those fantastic tales of how far we have already gone, which is in a way true, because if it were not true, I wouldn't be able to tell about the negatives of it. But I think you need to know about it. And the whole idea of branching, I think the 10th edition of Robbins has this image, which is from Darwin's original manuscript that he put down on paper when he went to the Galapagos Islands and tried to find out how the branching evolutionary process brought about the different types of birds that he observed. Now this analogy can be applied to the evolution of tumors. And in this case, evolution doesn't mean getting better, but means getting worse. The series evolution on a time scale. And I recently, as a matter of fact, yesterday, got a paper from a neurosurgeon. I have to write a critique of it. I got it from the editor of a journal that I will not have the name of, because honest to God, I should not be using these images, but I found it so wonderful, I decided I will. I will tell you, I will put these on the website, because this paper has not yet been published. But it deals with the problem, where does the neurosurgeon take the sample? And how does he come up with different tissue samples of different features, although both of them will have the features of a glioblastoma. And he also demonstrated, it's beyond belief, it's one of the best papers I've read in the last 10 years. He proves beyond doubt that a brain tumor, while it starts as a mass growing here and has cancer stem cells, but multiple types of cancer stem cells, even at the site of surgery. And he knows what he's talking about because he's a neurosurgeon. He is the one who takes that brain tumor out and then does the analysis with his colleagues and finds out that stem cells it's impossible to radically remove a brain tumor. You cannot see cells. There's always some that remain. And that is shown by the survival time, which in case of a glioblastoma is still, as we speak, it's about 14 months. But he not only showed that, but also showed that using different markers, he could find quiescent cancer stem cells, micro-infiltration of the brain, and I argued why I wrote my opinion about this paper. How does he know that these potentially tumorigenic cancer stem cells migrated from here and not arose de novo, reflecting the field theory? And this changes a lot. And I think that was the last, yes. So, tumors are often not monoclonal. They develop in a field. They have a non-linear evolution, and at the branching points have pluripotent cancer stem cells with different markers, both diagnostic, prognostic, and predictive. And sampling is so crucial that no matter how much money is spent on the analysis of the tumor, if the sample is not appropriate, the whole thing is for the birds, as they say. And the thing why I want you to understand is that I have personally talked to not one, tens of patients or relatives who came up to me and said, and I will never forget this story that I will leave you with now, a grandmother who came up to me and said his grandson, the only one, had a brain tumor, and she had heard that in China it is possible to treat that type of brain tumor with a stem cell. She had sold her house, spent the money on sending her grandson to China. and the whole thing was worse than horse shit. It's a tragedy. The child died, not surprisingly, and there was the grandmother without a house who committed suicide. And all this because most of the people who filled the news, TV, papers, the smartphones, the web, with false information, can create an atmosphere which gives hope to those people who would give anything for hope. And being critical, cautious but helpful in a situation like that is something that's not being taught in medical school. This is all something that you personally will have to find